Next is Bernoulli's theorem. So according to Bernoulli's equation, Bernoulli equation is states that at any point the sum of total mechanical energy is my constant, or we can write for the if my rho is constant, so we can write if my density is constant, or you can say that my flow is incompressible. In that case, we can write according to Bernoulli's principle P by rho g plus V square by 2g plus Z is equal to constant. This is my Bernoulli principle. So where P is my pressure, rho is my density, and Z means distance from the reference. Distance from the reference. Okay. So what are the assumptions when we are driving the Bernoulli's equation? So this equation can be derived when we are following the some assumptions. The assumption is my, I am writing down the assumptions. So assumption is very important. So first one is my, the fluid is ideal. Second one is my, the flow is steady. So steady means there is no change of the properties with respect to the time. That is called my steady equation. Next is my, the flow is incompressible. And last one is my, the flow is irrotational. So these are four assumptions that must be followed by to drive the Bernoulli's theorem. When we are driving the Bernoulli's theorem with the help of the Euler's equation, so these four assumptions must be followed by the Euler's equation. Otherwise, this equation, if flow is rotational, it means that this equation is not valid. If flow is my unsteady state, in unsteady state, it means that the this equation is not valid. If I am saying that the flow is compressible, this equation is not valid. Okay. So if I am writing down the statement, so according to the Bernoulli's theorem, if the flow is steady, incompressible, and ideal, the total energy at any point of the fluid is constant. Okay, so my pressure energy is my that is P by rho G. Kinetic energy V square by 2G, and data energy is my Z. According to Bernoulli principle, we can write P by rho G plus V square by 2G plus Z is equal to constant. So this is my Bernoulli principle. Okay. So the Bernoulli equation for the real fluid, I'm writing down the so Bernoulli equation for the real fluid is my P1 by rho G plus V1 square by 2G plus Z1. If I am considering 2 points, suppose this is my pipe and in this pipe the flow is happening and we are considering point 1 is here and point 2 is here, and this is my reference line and the value is reference is Z1, and from here the datum line is my Z2. So we can write Bernoulli's equation P1 by rho G. If I'm applying the Bernoulli's equation at two different points, that is my 1 and 2. So Bernoulli equation is, according to Bernoulli's equation, we can write P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2 and one more thing is added here in case of my real fluid, that is my head loss. So HL is basically refers to the head loss. Or you can say that loss of energy between point 1 and 2. Okay.